we are going to solve our next problem, which is the problem of the Leetcode. Today's problem, that is, we have to return a lexicographical orders of numbers, and what we have given an integer n, and we have written all the numbers from range to 1 to n in sorted in lexicographical order. So all the numbers in range in such a way that they are sorting in lexicographical order, and we have to write the solution in order of n time and order of one space. So first of all, we are going to discuss what is lexicographical order. So suppose we have n equals to 5. So what are the number from 1 to n? 1, 2, 3, 4 and 5, and they are like 1 is the smaller than 2, 2 is smaller than 3, 3 is smaller than 4, 4 is smaller than 5. This is sorted order. Yes, we return that number. Suppose we have n equals to 13. In this case, what we are going to do, what will be our number? What will be our numbers? Our numbers will be like first we have 1, then we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. These are the numbers, but the resultant is not the output we get is not same like that, because this is in sorted order, but it is in increasing order, not in lexicographical order. What does mean lexicographical order? Means like if a number is start with 1, all the numbers that are start with 1 will always be smaller than 2. Like 1 is smaller than 1, this is 1 is smaller than 2, this is the correct, but 1 0 10 is smaller than 2, this is the lexicographical order. Like 10 is always smaller than 2, 11 is always smaller than 2, 12 is always smaller than 2, and 13 is always smaller than 2. So we can see the answer it here like that. So how we can get the lexicographical order? So what we have to do, like suppose we have to suppose we start with 1, like we create all the numbers that are started with 1 and that are smaller than n. This can be a case like we create all the numbers which start with 1, 2, 3, like we create an I'm going to create something like 5 and then 6, 7. There are only 10 digits, 1 to 9. Sorry, 10. There are only 9 digits. So what we can do, we create all the numbers that start with 1. So what can be start with 1 and smaller than n? So n is here 13. So any number which start with 1, yes, 1 is always, then 1 0 10 is also, then 1 0 1 11 is also, 1 2 is also smaller than 3, 1 3 is also smaller than 13. But when we go for 1 4, which is 14, 14 is not smaller than 13, so we will stop there. We will not branch other things, and now we again move like the numbers which start like 1 0, then 1 0 0 number can be 100, which is not smaller than 13. We stop here. We stop here, then we like 1 0 1 1 0, stop here. 1 1 0 is not smaller than 13, then 1 2 0 is not smaller than 13, stop here. 1 3 0 is not smaller than 13, stop here. So these are the numbers which we generate. Like first we generate 1, then we generate 10. I should write, I should type like first we generate 1, then we have generated 10, then we have generated 11, then 12, then 13. We generate all the numbers which started with 1 and smaller than 13. Right, now our work is done. Now what we are going to do, we I should now now we what we are going to do, we generate all the numbers which are smaller than 2, which are started with 2 and smaller than 13. So 2 0, a number which 2 is the number which started with 2. So what we are going to do is this is the, we add here 2. Now the number which start with 2, 2 0 can be a number, but 2 0 becomes 20, which is not smaller than 13. So we will not branch here, we stop here. Then we again start with 3. 3 can be a 3 is smaller than 13, and now we will generate all the numbers which start with 3. 30, a number which can be the first number 30. So 30, which is not smaller than 13. Stop here. Now we move for the 4. We generate all the numbers which start with 4. So 4 is smaller than 13. Now we move to 40, which is not smaller. So all the numbers now move ahead are not smaller than the 13. Like 7, 5, 6, 7, 8, 9 are the smaller. But the numbers which we are generating by adding some element with that will not be smaller than this. So how we can do this? Like you can see, like there is kind of DFS. Like we start with 1, we go into 0, 0, 0, we are going to into depth. Then if we hit the base case, then we return from there and explore other path. Return, explore other path. Return, explore other path. Right? So this question will be solved by using DFS only. And we are using DFS here, right? So this is the resultant, this is the number, and now I am going to do, like we start always from 1, right? So what kind of a DFS? Like we make a for loop. I will show you a solution. So like what we this is the vector we are going to store our result. Okay, now we start with 1. Like all the numbers which start with 1 means we start with 1 and smaller than 13. Explore all those numbers and put into them. So we make a DFS call for all the numbers which start with 1. We make again, if we return from 1, then we go to 2. All the numbers which start with 2 and less than 13, make DFS call. Start with 3, make DFS call, like that. Okay. So here what we are going to do here is that we pass the numbers from it is started. Like either it start with 1, either it start with 2, either it start with 3. Any number that we have generated till now, and we have passed the resultant array by pass by reference. Means pass by reference means we are passing the address. All the changes will be made into the original array. Okay, and we have the target value, like and we have to generate all the numbers from a range 1 to n. So num should not exceed n. So here we have test base case. In base case, what we have, if our number which is greater than our range, we cannot include that number, we return from there. So this is the base case. If the number is not not the if the number is in the range, means 1 to n, in that case we push that number into our array and we explore all the paths start with that number. Like we pass 1 initially, like, and if we want to explore like 1 0, 1 1, 1 2, how we can get like that, this kind of a number. So what we are going to do, what num we have into 10 plus 1 plus I into 10 plus I, that is the formula we are going to use to generate the numbers. Like if we have 16, right, if we have 16, we want to add 5 at the end, so we want to make it 165. How we can make it 165? Like one digit is added means we have to multiply it by 10 and then we have to add something, right? So 16 into 10 is 160 plus 5 is 165. Same case here is like we are adding num into 10 plus I. What we want to add, like 1, we want to add 0 to 1 0. Then we have 1, we want to make 11. So 1 into 10 plus 1, 11. 1 into 10 plus 2, 12. Same for this, and we make the DFS call. And now we are going to talk about the time complexity and the space complexity. I haven't discussed the brute force approach. Brute force approach is very simple, in which what we can do, we generate all the numbers from 1 to n, convert them into a string and push them into a vector data structure, vector of a string, and then we store that vector and then convert back string to integers and return the resultant array. This is very basic approach, and the time complexity of that approach would be n log n, because we will be using the sorting algo, and the space complexity, we are using extra space for storing the uh, strings of all the integers. So it will take extra space, that would be order of n. So we are going to discuss the time complexity of this approach. So what is the time complexity? Like this for loop is only going for 9 times, right? This is for loop only going for 9 times. This for loop is always going to n times, always. Like this for loop is always 0 to 9 10 times. So overall our time complexity is always order of n, because it if the number is greater than n, we are not going to uh, explore that number, we return from there. So time complexity is order of n only. And the space complexity, we are not using extra space, so space complexity would be order of 1, but